In this video, I'd like to give an introduction to the topic of inverse functions. So what is an inverse function? In simple terms, an inverse function basically reverses the operation of a function. We've actually come across many inverse functions already in both primary and junior mathematics. For example, the process of addition and subtraction are inverse functions of one another. Multiplication and division are also inverse functions of one another. If we square a number and we want to undo the effect of squaring, we can take the square root of the number. Logarithms and exponentials are also inverse functions of one another. In this video, we're going to extend beyond these basic functions to look at more complex mathematical functions. Given the function f of x, we can write its inverse function using the notation f to the negative 1 of x. Now be careful, f to the negative 1 of x isn't the same as 1 on f of x. If we want to write 1 on f of x, we would write this as f of x all to the negative 1. Let's look at the relationships between f of x and f to the negative 1 of x. Suppose I've got a function f of x defined to be equal to 3x. We're going to give it input of x is equal to 2. 2 gets multiplied to 3, and this is going to give us the output of y is equal to 6. Now let's say we want to go back to retrieve our original input. What we're going to do is introduce the inverse function f to the negative 1 of x, which is equal to x on 3. And we're going to take the output y is equal to 6 and make this the input into our inverse function. So x is equal to 6 goes in, the inverse function gets applied, so we have 6 divided by 3, and this is going to give us the output of y is equal to 2. Now several things to note. Firstly, the output y from f of x becomes the input x into our inverse function. Second, the output y from our inverse function returns the original input into our function f of x. What we see here is that there is an interchange of variables x and y between f of x and f to the negative 1 of x, and this leads to some very important properties. Since there's an interchange of variables x and y between f of x and its inverse function f to the negative 1 of x, this means that if we're given the equation for f of x and we would like to find the equation for f to the negative 1 of x, all we need to do is to simply swap the x and the y variables, rearrange the equation to make y the subject. Another thing we saw was that the output of one function became the input of the other and vice versa. This means that the domain of f of x will be equal to the range of its inverse f to the negative 1 of x, and the range of f of x will be equal to the domain of the inverse f to the negative 1 of x. And in terms of the geometrical property, if we were to graph the two functions, f of x and its inverse, both of these functions will be symmetrical about the line y is equal to x. So let's now look at some examples. For our example, we're going to be finding the inverse function corresponding to each of these functions below, as well as determining its domain and range. For our first example, we've got the function f of x defined as y is equal to 2x minus 1. In order to find the inverse function, we need to swap the x and the y variable. So the y gets replaced by x and the x gets replaced by y. We now need to rearrange the equation to make y the subject. First, we add 1 to both sides, and this is going to give us x plus 1 is equal to 2y. We then divide both sides by 2. So we have y is equal to x plus 1 all over 2. So this means that our inverse function, f to the negative 1 of x, is defined as y is equal to x plus 1 all over 2, or we can split this into two fractions such that we write it as y is equal to half x plus a half. So let's consider the domain and ranges for these functions. For our original function f of x, y is equal to 2x minus 1 is a straight line with gradient of 2 and y-intercept of -1. This means that its domain is going to be all real x and the range will be all real y. For our inverse function, half x plus a half, this is also the equation of a straight line with gradient a half and y-intercept of a half. So its domain will also be all real x and the range will also be all real y. We can see that the domain of one is equal to the range of the other. And here's the graphs of f of x, f to the -1 of x. And what we see here again is that these two functions is symmetrical about the line y is equal to x. Our next example, we've got the function f of x defined as y is equal to 1 on x minus 2. To find the inverse function, we're going to again swap the x and the y variables. The y gets swapped to x and the x gets swapped to y. So we now have x is equal to 1 over y minus 2. To make y the subject, we're going to first take the reciprocal of both sides. So we have y minus 2 is equal to 1 on x, and then we're going to add 2 to both sides. So we have y is equal to 1 on x plus 2. So therefore, our inverse function, f to the -1 on x, is defined as y is equal to 1 on x plus 2. Considering now the domain and range of both of these functions, f of x, y is equal to 1 on x minus 2 is a hyperbola with a vertical asymptote at x is equal to 2. The domain of this function will be all real x except x can't equal to 2. The range will be all real y can't equal to 0. For the inverse function, we have the equation y is equal to 1 on x plus 2. Again, this is a hyperbola. The domain of the inverse function is going to be all real x with x not being equal to 0. And the range of our inverse is going to be all real y can't equal to 2. And we see here that the domain of the function f is equal to the range of the inverse and vice versa. And here are the graphs of our function f of x, the inverse function f to the -1 of x. And we see once again that the two functions are symmetrical about the line y is equal to x. Our last example, we've got the function f of x defined as y is equal to 2 to the x minus 1 plus 2. This is an exponential function. To find the inverse function, we're going to swap the x and the y variables so that the y becomes x and the x becomes y. We're now going to rearrange this equation to make y the subject. First, we're going to subtract 2 from both sides so that we get x minus 2 is equal to 2 to the y minus 1. In order to get rid of the base 2, we now need to take the logarithm of both sides. So we're going to get log base 2 of x minus 2 is equal to log base 2 of 2 to the y minus 1. The log and the exponentials are inverse functions, so they're going to cancel each other out. So we're going to get log base 2 of x minus 2 is equal to y minus 1. We then add 1 to both sides. So we have now our inverse function defined as y is equal to log base 2 of x minus 2 plus 1. Let's now look at the domains and ranges of these two functions. For our original function f of x, we've got the exponential function that's been shifted 1 unit to the right and upwards by 2 units. This means that the domain of our function is going to be all real x, but the range will be y is greater than 2. For the inverse function, we've got the log function that's been shifted 2 units to the right and shifted upwards by 1. The domain of our log function is going to be x is greater than 2, but the range of our log function is going to be all real y. Again, we can see that there is a correspondence between the domain of one with the range of the other. And here are the graphs of f of x and inverse f of x. So the blue graph is our exponential function. The red graph is our log function, and we can see that both of these functions are symmetrical about the line y is equal to x. Here's a summary of what we've learned so far. Firstly, an inverse function basically reverses the operation of a function. Second, there is an interchange of variables x and y between f of x and its inverse f to the negative 1 of x. This means that the domain of one will be equal to the range of the other, and the range of one will be equal to the domain of the other. And lastly, if we were to look at the graphs of f of x and its inverse, we're going to notice that both of these graphs are symmetrical about the line y is equal to x. So far in this video, we've only focused on one-to-one functions. However, not all functions are one-to-one. So in the next video, we're going to extend on this and we're going to look at how to restrict the domain of many-to-one functions in order for us to be able to create inverse functions. So hope to see you all there. Bye for now.